The following is the video solution from JSDT Solutions. Question 8 says, in the diagram, C is the foot of a vertical building and D is the top of the same building. The height of the building, CD, is 16 meters, as we can see. Two observers are standing 19 meters apart at points A and B, where A, B, and C lie in the same horizontal plane. Okay, so that's like the ground. A painter is working at point E on the building. The angle of elevation of D from A is 46.85 degrees. And then angle DEB is equal to 122 degrees, and angle BCA is equal to this angle over here is equal to 105.61 degrees. And the first question is to calculate the length of AC, the distance between the observer A and the foot of the building. Okay, so find AC. How can we find AC? Okay, so to find AC, just look at the triangles that it's a part of. AC is a part of this triangle, yes, but it's not a good idea to use this one right now because the only thing we have are these two. Okay, AC is missing. You don't even have this angle here, so we cannot even use the sine rule here. So we can focus on this triangle. We have a right angle triangle. We have one side in the triangle and one angle, so we have more than enough. So we can see from this that AC in reference to the angle is the adjacent side. It's next to this angle. And then the only other side we have would be 16. In reference to this angle, that is the opposite side. So we have an opposite and an adjacent side. So which function will we use? We will use tan. So we say tan of our angle, which is 46.85 degrees, is equal to the opposite side, which is 16, over the adjacent side, which is AC, and that's what we're looking for. So all we have to do now is make AC the subject of this equation. You can do so by cross multiplying or by transposing. So you see this says divided by AC on this side. When it goes over, it's no longer going to be in the denominator, it will be in the numerator, AC. And this one, right now, it's actually on the numerator because there's an invisible denominator of 1. So when it goes over, it will go to the denominator. So you'll still have 16 here over tan of 46.85 degrees. And we just have to find this. So that's going to round up and add a 1 there, add a 1. And so it ends up just being 15 units. And that is our answer for AC. Question 8.2 says, calculate how far the painter at E is from the top of the building. So how far the painter at E is from the top of the building. So that is the line ED. That's what we need to find. Okay, so knowing now that AC is 15 units, how do we find ED? Do you see that ED, for you to find ED, you would need to know what EC is, since we already know what AD is. So if you take AD and you knew the length of EC, if you say AD minus EC, you will get ED. So the main goal here would be to find ED, you need to find EC. Okay, so how can we find EC? Well, EC is part of a right angle triangle, which is great. With the right angle triangles, like you saw with this one, all you need is an angle and an available side, and then you can find another side in the triangle. So you see that because it's a right angle triangle, in the previous triangle, all you need to find a side is an angle and another side. If this is a right angle triangle, you'd be able to find another side. So we would just need an angle and another side. Do you see that we can easily find this angle? Okay, since this measures as 122 degrees, and so these are the angles on a straight line. So we just need one side here. Let's see which side we can actually find. So EB is definitely out of question because it's just way off. But then BC is one of the shared sides with this triangle on the bottom. So we could try finding BC. How would we find BC? If we're looking for BC, what we could do is we could use the sine rule. So to use the sine rule, we have this side, and then you would have to pair this with the angle opposite that side, which is this angle here, CAB. So we need angle CAB. You see how we travel throughout this diagram? How we initially needed ED, but then now we need EC, and now we need BC, and now we need this angle. Okay, so to find this angle, we could focus on finding this angle. Okay, if we find this angle, we'll be able to find this angle. Now, here's why we can find this angle. Because we have 15 over here. This is 15 units, and we have this that we're looking for. And then we can pair that up. So long, let's just leave this. We can pair that up with this. So we're going to use the sine rule here. Because we are looking for an angle, make sure you put the angle first. So this is how we can write this. We'll say sine of this angle B, but it's actually angle ABC. So let's just call it that. We'll say sine of angle ABC over, and then over the side that it's opposite. That angle is opposite that side AC, which is 15 units. So over 15 is equal to, and then you need to pair it with another side in the same order. So sine of an angle. So you see how this is already complete. We've got the angle and the side. So we can say sine of 105.61 degrees, sine 105.61 degrees over the side opposite it, which was 19 units. So we can use this to find angle ABC. You see that the only way we can solve for this is to get rid of this 15. It's on the denominator now, so if you transpose it, it's going to be on the numerator. In other words, you can multiply both hand sides by 15. So sine ABC is equal to 15 sine 105.61 degrees over 19. And then to solve for this angle, you can use the second function of sine. It's kind of like taking sine over. So ABC is equal to, it's going to become shift sine on the calculator and then everything here. Okay, so the angle ABC is currently just 49 points, but I'm not going to round off. I'll just leave it like this for now. And then anything else that we have to calculate, we'll just have to calculate by ourselves. Okay, so we've got ABC. The main goal here is not to lose track of what you were trying to do. So since this was just 49 points, we'll call it 49.5 for now. Since we have this, we can finally use that to find this angle. That's what we were looking for, because this angle will help us to find BC and BC will help us to find EC. So you see that you can simply just use the angles in a triangle. The angles in a triangle add up to 180 degrees. So this angle BAC is 180 degrees minus this angle and minus the 105.61 degrees. Okay, so on our calculator, we can simply just say 180 degrees minus the 105.61 minus our answer that we had. And we'll hold on to this and make sure that we don't round off. So I'll just call it 8945 and I won't round off yet. Okay, so this angle, and we might as well just leave that one like the way it was supposed to be. Okay, so as 49, and this one, we can just go ahead and call that 24.89. Okay, it's just for us to understand where we are going. Okay, so now that we have this, we can find BC. And we will find BC using the sine rule. So we want BC, so we need to use the angle opposite it as well. And then take another pair that is complete. It's safe to take these ones since this was already rounded off, okay? So we don't have to overthink using this. Okay, so this time, BC is what you're looking for. You're looking for a side. So we're going to ensure that we put that side first using the sine rule. So it's going to be BC over sine of the angle opposite it, which was sine of this angle that we currently have, which is equal to, and we're going to just take this pair, the 105.61 and 19. So it's equal to, you have to follow the same order. So side over the sine of the angle. So sine of 105.61. Okay, and now to make BC the subject, you see that this is the only thing in the way and it's in the denominator. So to get rid of it, you multiply both hand sides by that same thing. So what will happen is it will move to the numerator, and now we have BC is equal to 19, and then sine 24 point, we won't round off, we'll just use that as ounce, over, and then sine of 105.61. Okay, so BC is now equal to 8.3043. Okay, we still won't round off. And let's just see, now that we have BC, we can finally find, so this is 8.30, we can finally find EC. So do you see that this is part of a right angle triangle? So we just need one single angle and we'll be able to do this. Okay, we can either use the rule that these add up to 180 degrees or that this is the exterior angle of this triangle. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. But it's easier to just use the angles on a straight line. So what is 122 degrees? 180 degrees minus 122 degrees is 58. So we know this is 58 degrees. Okay, so that was just the only little calculation we would have needed to do without a calculator. So that is 58 degrees. And now this is very helpful. So we can just also note down that BEC is equal to 58 degrees. Okay, that is BEC. And now let's go ahead and see what we can find here. So we've got an angle, we've got a side, and we can use this to find EC. So relative to this angle, EC is where? EC is next to the angle, so it is the adjacent side. Okay, the adjacent side is next to it. And then BC, the only other side we have to use, is opposite that angle. So we just have to find their positions. So we know we are using opposite and adjacent, and that is TOA. So we know we are using tan from SOHCAHTOA. So we'll say tan of 58 degrees is equal to opposite over adjacent. So 8.30 over EC. Okay, so you see that as we have this now, to get EC to be the subject, you could multiply both hand sides by EC, but you could also just transpose. So you have EC is equal to, and then you want this to leave so that EC is on its own. This is currently on the numerator because it has a natural denominator of 1. So this is still in the numerator, 8.343. And then we're going to say, that's not degrees, that's a side. Okay, and that's going to be tan 58 degrees over tan 58 degrees. And let's find EC. And EC, and this is the point where we can round off, because EC is just the last length we're trying to find to help us to find this. This is already a whole number, so you just have to round off to whatever rounding we need to work with. The exam paper says round off to 2 decimal places unless stated otherwise, so we will round off to 2 decimal places at this point. So that makes EC equal to 5 points, and that adds a 1 to the 8, so 19. Okay, so that's what EC is, and these are in meters. Okay, we should have also said that for BC. This is meters. Okay, so now that we have that, we can finally find this. So we were looking specifically for the length of ED, and you can see now that to find ED, you will simply take the entire length of DC and then say minus EC, and that will give you ED. So ED is equal to 16 minus 5.19, and that will be ED. Okay, which is just going to be 10.81 meters, and that is our final answer. The length of ED is 10.81 meters. Okay, and that is it for question 8.